Now I'm going to flip backwards to the extension or the second step photograph here. So when you're talking about lighting bouncing around the model and lighting up surfaces and darkening others and causing reflections and so forth, what we need to talk about next is what a rendering extension is actually doing in SketchUp. So flipping to the first image, SketchUp has a concept of a direct sunlight. So that sunlight is coming from somewhere in a direction and it's hitting a surface of different things in the object or in the model. And when it hits that surface, it lights it a certain way. Well, in the real world, once light hits a surface, it sort of either gets swallowed up by that surface or it reflects off of it. Obviously, a mirror, it's reflecting, whereas maybe black fabric, it's almost entirely being swallowed up. But things are bouncing light around. So you go back to the extension and all of a sudden the light softens, bounces around. So what are light bounces? Well, in an extension, there's a concept called ray tracing. I'm going to flip to a SketchUp model to try to highlight what ray tracing is. So this is a SketchUp model, a very, very basic SketchUp model of a house. And in SketchUp, you have a concept of direct sunlight. Right now I don't have any shadows turned on, so we don't really have the direct sunlight happening. But as I'm orbiting around, this face here looks kind of one shade of white, but if I orbit to the side here, it looks an entirely different shade of white, even though we know that the color hasn't actually changed. So in general, in any three-dimensional world, you're talking about what is the surface, where is it, and sort of what its orientation to the light source is, and then its orientation to you, the viewer or the camera. So I've actually created a really basic thing here. I'll turn on my layers and check on a layer, and I'll zoom out. So what I want to talk about when we think about ray tracing is if there's a pixel, so the pixel here is represented by two lines I have drawn from these objects hitting the side of the house here. So there's this pixel that's at the point where these two lines meet. And if we're talking about what is the color of that pixel, or in other words, what are the light conditions at that pixel, then ray tracing helps us figure that out. Ray tracing is a math equation used by rendering extensions. And what it essentially says is there's a virtual camera represented by this sort of camera icon here. And at any time, that virtual camera is represented by what you, the viewer, are looking at. So if I was looking from this camera, there was a direct line of sight to this pixel. Now, this pixel is going to shoot some information down that line to the camera and say, hey, I'm this color. But what is the color that it's going to tell? Well, one is it's going to take its existing color, whether that be white or if this was brick and it was some shade of red or something like that. But it needs more information. So what it also sends is at the point that it would bounce off towards the light source and the light source back at it, it's going to have another ray or line that's going to go to the light source and say, okay, light source, how big are you? What is your distance from the surface here to the light source? And what's the brightness of the light source? And of course, too, if there's any color information, like for example, if the light was a blue light rather than sunlight or something like that, an artificial light, for example. So you have light traveling to a pixel or to a surface more properly. That surface then is oriented a certain way towards the camera. So it changes color depending on which way you're looking at it. So this is all just a very simple diagram. This will make more sense as we go along, but later on when we start rendering our own models, it'll be really important to always remember how big is the light source, how bright is it, how close is it, and its general orientation to a surface, but then too, what is your being the viewer, what's your camera angle on it or your virtual camera view on it? So you may not have a camera, but whatever you see in your entire model is sort of your orientation to a surface. And how zoomed in or out are you? All of these things are going to play a huge role in what is the final color of that pixel. So we'll refer to this file as we go along and refer to the concept of ray tracing as we go along. but just important to know that information right now.